Each time you walk, do you think about how you walk? How do you move forward? What really happens? Why do you feel slippery on ice? Let's take a look at that in this video. The same principle that allows you to walk forward is a principle that allows cars to move forward or around a bend. Friction. It is a force that prevents two objects from slipping or sliding against each other. We can define two kinds of friction, static and kinetic friction. First, let's look at static friction. Like the word static entails, it is a frictional force that occurs when two objects are not moving relative to each other. Well, here's where walking comes in. When you're walking forward, you're applying a force against the ground. In turn, the ground is applying a force back against you. This is through Newton's third law. The force that the ground applies back on you doesn't come out of nowhere. It's static friction. Now, when you slip sometimes, that's kinetic friction. Static friction only occurs between two objects that are motionless relative to each other. These same principles are also what allows cars to move forward and cars to round bends. The frictional force provides a net force that actually moves the car forward. No, friction does not necessarily impede motion. Additionally, when a car wants to turn a bend without friction, the car would slip and go in a straight line. After all, moving along a curve requires a centripetal force. What can apply this centripetal force? Friction. Why don't we introduce some equations? We can define the frictional force as a force that is less than or equal to mu s, which is the coefficient of friction between two surfaces, as shown in the following chart, multiplied by the normal force. This normal force is essentially the force that the surface has on the other surface. So, you may wonder, why is it less than or equal to? Let's look at a block on a table. Say the block has a weight of 5 newtons. Furthermore, let's say it's wood on wood. This means that the frictional force can range from 0 to mu s times n. Say you apply a force of 2 newtons. Is the frictional force going to be equal to 2 newtons, or is it going to be at its maximum? Obviously, it's not going to be at its maximum of, let's say, 5 newtons. Otherwise, the net force would be toward the left and it would start going backwards. This makes no sense, thus why there is a less than or equal to sign. For a car going in a circle, let's look at some of the physics behind it. The frictional force must provide the centripetal force, so we can equate the static friction force to the centripetal force calculated through mv squared over r, assuming a flat surface. This can give us some insight into whether or not a car will go sliding across the road if it's traveling too fast, just like the NASCAR videos. Next, let's look at kinetic friction, or sliding friction. This type of friction occurs when two surfaces are moving against each other, the type of friction that occurs when you slip. Although it can be greater than static friction, we generally see kinetic friction as being weaker than static friction. Kinetic friction results in a force that opposes the direction that the object is moving toward. So, say we have a block that is moving across a wood table. The kinetic friction would be opposite to the direction of the velocity. We can define kinetic friction by the formula F equals mu k times n. Relating back to our previous example, kinetic friction acts on cars when they slip. So when you see a race car veer off the track, the static friction that was keeping the car going in a circle is gone, and the car will start to slide. Hence, when the force from static friction is not great enough, it will turn into kinetic friction. Using these equations, we can perhaps model the frictional force on an object as a force that is slowly applied to it. As the force increases, the frictional force will also increase proportionally. This force right now is static friction. However, once we reach that point where the applied force is greater than the static frictional force, the force from friction becomes kinetic friction. Thus, we see a drop in the graph as the force from kinetic friction is generally less than the force from static friction.